Hello friends, good day. Today we will be discussing latent variable in the context of machine learning models and others. So as an introduction, latent variables are an essential concept in statistics, machine learning and various scientific disciplines, particularly in the areas involving complex data analysis and modeling. Unlike observable variables, which can be directly measured or observed, latent variables represent underlying factors or constructs that are not directly observable but are inferred from other measurable variables. In simple terms, a latent variable is a hidden or unobservable variable that influences observed data. These variables are not directly measurable but are inferred through mathematical models that relate them to observable data. For example, consider the concept of intelligence. Intelligence cannot be directly observed or measured, but it can be inferred through measurable indicators such as performance on tests, problem-solving skills, or decision-making abilities, etc. Intelligence in this case is a latent variable. Continuous latent variables, these are unobservable variables that take on continuous values. Examples include intelligence, socioeconomic status, or health. In machine learning, continuous latent variables often appear in the probabilistic models like Gaussian mixture models and factored analysis. Few words on categorical latent variables. These are unobservable variables that represent discrete categories or groups. For instance, a person's mood, happy, sad, or neutral, or personality type, introvert, extrovert, can be treated as categorical latent variables. These types of variables are often used in models like latent class analysis and hidden Markov models. Importance of latent variables in different areas. Say in psychometric, in physiological testing and educational assessments, latent variables are used to measurable attributes like intelligence, anxiety, motivation, and personality traits. For example, in IQ testing, latent variables represent the intelligence level that is inferred from the performance on various tasks. So that is psychometrics. Then social sciences researchers use latent variables to study complex constructs like attitude, beliefs, and social status. Structural equation modeling (SEM) is a popular method in social sciences where latent variables are used to explore relationships between observed and unobserved variables. Machine learning in unsupervised learning models unsupervised learning models like principal component analysis, latent variable captures underlying features or dimensions in high dimensional data such as in image or text analysis. In deep learning, latent variables play a crucial role in autoencoders and variational autoencoders, where they help represent compressed representations of input data. In economics modeling, latent variables are used to describe concepts like market sentiment or consumer preferences, which are not directly measurable but influence observable economic behavior. Some examples, say in factor analysis, a technique used to describe variability among observed variables in terms of fewer unobserved variables called factors or latent variables. For example, in psychology, factor analysis is used to find underlying factors influencing performance on cognitive tests. Then latent dirichlet allocation (LDA), a widely used topic modeling algorithm in natural language processing that represents documents as mixtures or of latent topics. These topics are inferred from the words in the document, making topics that latent variables. Hidden Markov models, a probabilistic model where system being modeled is assumed to be a Markov process with hidden or latent states. HMMs are widely used in time series analysis, speech recognition, and bioinformatics. Finally, structural equation modeling, a combination of factor analysis and regression models used to analyze structural relationships between latent and observable variables and observed variables. Some benefits: simplification of complex models. Latent variables allow researchers and data scientists to capture underlying structure that explain complex relationships in the data. This leads to more interpretable models and reduce the dimensionality of data. Increase model accuracy. By accounting for hidden factors, models that include latent variables often result in more accurate predictions or estimates. Theoretical insight. Latent variables offer insights into abstract constructs and theories that cannot be directly measured, providing a deeper understanding of human behavior, social trends, or hidden patterns in data. There are challenges while with using latent variables. Model identification. Estimating latent variables can be difficult since they are not directly observable. This requires complex mathematical models and assumptions which may not always hold true. Interpretation. In some cases, latent variables can be difficult to interpret or explain, especially in high-dimensional models where the meaning of the latent variable may not be clear. Overfitting. Introducing too many latent variables in a model can lead to overfitting, where model becomes too tailored to the training data and performs poorly on new ones in data. So these are the challenges. Finally, some concluding words. Latent variables provide a powerful way to understand hidden patterns and structures within data. While they cannot be directly observed, they play a critical role in simplifying complex systems, enhancing predictive accuracy, and providing theoretical insights into a wide range of phenomena. Whether in psychology, economics, or machine learning, latent variables help bridge the gap between what we observed and what truly drives behavior, performance, and outcomes. I'll stop here. This entire talk is based on the article Geek for Geeks from Geek for Geeks. Thank you. Like, comment, share, subscribe my video. I am available for one-to-one sessions too. Thank you.